Okay, today we're going to take a look at a special type of differential equation that we call a separable differential equation. If something is a separable differential equation, dy dx is equal to a product of a function of x and a function of y. And it's really important here that it's a product, not a sum or a difference, but two functions multiplied together. So dy dx is 2x times y squared. So we have a product of two functions, 2x and y squared. And the way we solve a separable differential equation is, sort of as the name implies, we separate. So we move the x's to the right side and the y's to the left side. So we divide by y squared, we multiply by dx. Rewrite that 1 over y squared as y to the negative 2. So we take the integral of each side. And whenever we take an indefinite integral, we get a constant of integration, and we have one for each side. So we have c sub 1 on the left, we'll call it c sub 2 on the right. But since those are both constants, we could just subtract c sub 1 from each side of the equation and combine these both into just one constant, we'll call it c. We can solve this equation for y, so we get y equals 1 over x squared plus c. And notice the x squared plus c is all on the bottom of that fraction there, so our constant is no longer just hanging out at the very end, it's actually inside of the function. All right, let's take a look at another one here. So we have a product of functions. We have a function of x, which would be 2x times e to the power of x squared, and a function of y, which would be 1 plus y squared. So if we go and separate, divide by 1 plus y squared, multiply by dx. We'll throw on our antiderivatives. Now, in order to take the antiderivative of the right side, we're going to use u substitution. Let u equal x squared. The derivative of that is 2x dx. The left side, I guess for now we've left it alone. On the right side, we have the integral of just e to the u, which is e to the u. The integral of 1 over 1 plus y squared is inverse tangent. Plug x squared back in for u. And notice as I went through this, I didn't bother adding c sub 1 to the left and c sub 2 to the right. I just had one constant on the right-hand side. Okay, we can still get y by itself if we take the tangent of both sides. The tangent of inverse tangent just gives us y. So y equals the tangent of e to the power of x squared plus c. And notice, really important here, that c is inside the tangent function. We can't try to somehow move that to the outside because the distributive property does not work with trig functions. If it's inside that tangent, it's inside that tangent. Our calculator could do this. So this is one method to get to the differential equation solver. You could also go to your catalog and go down to D, look for DE solve. So y prime equals, type in our equation there, solve for x and y. Hit enter. And notice the calculator gives us our answer in terms of inverse tangent. It'd be up to us then if we wanted to rewrite this to get that y by itself like we did on the previous slide.